Hi, you want to find some critical points using implicit differentiation? I sure do. Why implicit? Good luck trying to graph that. It's not a function, okay? So we're going to take the derivative of that. I'll go ahead and warn you, it's going to involve a lot of product rule. And just so it'll look a little more obvious, it'll be bigger on the board, I'm going to write it again under here. And we have to find the coordinate, x and y, of each critical point, similar to the last problem we had done. So we have x, not with this marker. That's not the best marker. It's better right there. And it's louder too, you just heard it. Sorry about that. Minus 2x squared y. You had your headphones on, you're listening to it, and we went right in the microphone. Sorry. Anyway, we're going to do the product rule. I'll do one of them in green, one of them in red. That's just kind of how I'm going to roll. So let's treat this one like f and that one like g. And then we'll do the product rule again with this as f and that as g. It looks like it's a frowny face. There we go. All right. Getting serious. The glasses are coming up on top of the head. So f prime's 1g plus f g prime 2y dy over dx. There we go. We just took care of the green product rule. So just in case you need to see it again, it's f prime g plus f g prime. And then we're going to do the red product rule, which of course will be f prime g plus f g prime. And that's going to equal 0 because the derivative of 1, of course, is 0. And then we're going to have to do a little more solving. We're going to set it equal to 0 or see where it doesn't exist or whatever. So f prime minus 4x g would be y plus f, so minus 2x squared, g prime would be 1 dy dx. Okay, let's get all our dy dx's on the same side, move everything to the other side, simplify a few things along the way. These two terms can go to the other side. That gives me 4xy and negative y squared. 4xy minus y squared. Let's factor out a dy over dx. And we will now have 2xy minus 2x squared. Oh, fun. Okay, dy dx, dy over dx, I should say, but we say dy dx for brevity. 4xy minus y squared over 2xy minus 2x squared. Looking at that, making sure everything's right. If something's wrong, we have to start the video over, and that's not worth it, so let's not do that. That sure would be a shame if that happened. I've had to do it several times in my life. So I may as well look here, and it looks good to me. Okay, we need to know everywhere that this equals 0 and this doesn't exist. So we're going to set this equal to 0. And we're going to solve that. When we solve that, we're looking at our numerator, and we're saying, well, where does this numerator equal 0? And also, we actually need to consider where the denominator equals 0, because we're going to consider where this derivative does not exist. So taking this idea, bringing it up here, I'm going to stand in the way. You won't be able to see a thing. It's okay. You'll be all right. 4xy minus y squared equals 0. If a fraction equals 0, it's the numerator that equals 0. If a fraction does not exist, it's the denominator that equals 0. And if the fraction is undefined, then yeah. So we'll take care of that one in a minute. But let's tackle this one first. So, how can I go about this? I don't know. I'm in panic mode right now. I'm kidding. Y, and then I'm going to factor out a GCF. 4x minus y equals 0. So we're going to set each of those factors equal to 0. Now, the brief panic mode I had is, I've worked it out, but it's off camera. It's sitting on a desk over here. But the brief panic mode I had was we still have two variables. So eventually, final answer is going to be an x and a y. But in the process of solving, we're going to need one variable. But we'll get there. So don't panic if you're not there yet, he said to himself. So don't panic. 4x minus y equals 0. So y equals 0 is an option. Maybe y is equal to 0. Or maybe 4x is equal to y. And that'll get us somewhere. Okay, that'll take us somewhere in a minute. So we need to consider a few things. We need to consider everywhere that y is equal to 0. And we also need to consider everywhere that y is equal to 4x. And again, we'll tackle that one in a minute. Can we go ahead and talk about the fact that y equals 0 is a terrible, terrible idea? So if, and don't write this, but I'm going to. Sorry, that was right there in the microphone, wasn't it? If you wanted to go ahead and start writing answers, you'd say, oh, I need coordinates. Let's go ahead and write them in red. And so 0 goes here, and then I have to find out the corresponding x value. Good luck with that. And here's why that doesn't work. if I plugged 0 into the original, I almost said function, but the original equation, I'm going to do it here in this big one, I would have x times 0, so 0x, spells ox, minus 2x squared times 0, so minus 0 x squared equals 1. Well, 0 equals 1. Good luck with that. That's not going to work. So therefore, y equals 0 is not a thing. That's not going to happen. We will get no answers from that one. So it's always a good idea to go back, plug that in. So, yeah, psych, no answers from that. Let's keep going. Awkward pause. Let's find out all the coordinates where y equals 4x. This is going to take a little bit more work. So going back to the original, written here, also written here, and everywhere I see a y, I'm going to put a 4x, and then we're going to work this out. Might be a little tricky, but we'll get it. So, doodly doodly doo doo. I'm going to plug 4x in for every y. So x times 4x squared minus 2x squared times 4x equals 1. And we're going to solve this for whatever variable is left, which is obviously x. We'll plug it back in. We'll get a y. So we have 4 times 4, so 16x cubed, x squared times x, 8x cubed equals 1. Oh man, this is going to be beautiful. This one's going to work out quite nicely. You're going to love it. So 16x cubed minus 8x cubed is 8x cubed equals 1. We divide by 8. X cubed equals 1/8. And x equals the cube root of 1 over 8. Don't panic. Cube root of 1. 1 cube root of 8. 2. X is 1/2. We now have half, literally, of an answer. We have a coordinate, or at least the x part of it. We still need the y. So we have 1/2 comma something. And I'm going to plug that in and find out what y is. And this is going to be the super easy part. So if 4x equals y, then 4 times 1/2 equals y. You can do this in your head, but I would hate to just say it and not write it and you not have a visual for what's happening. We're finding the y that corresponds to that x. So 2 equals y. So final answer, but not done, is 2. 1/2 comma 2. Not done? How are we not done? Critical points exist everywhere the derivative equals 0. Check. Everywhere the derivative doesn't exist. I haven't done that yet. Okay, this is where the derivative equals 0. Now we're going to see where the derivative doesn't exist. That would be if the denominator is equal to 0. So making more space, making more space. I'm going to start making more space. I'm going to sing about it too, apparently. 2xy minus 2x squared equals 0. 2xy minus 2x squared equals 0. And we're going to solve that, because this could be where the derivative doesn't exist, right? We might have some sort of graph. I have no idea what this looks like. But we might have some sort of graph that goes, woo, like that, okay? And at that point right there, we're going to have a critical point, which could be, in this case, a minimum. And at this point, we would have where the derivative equals 0. Actually, at that one, we would too, if it's truly cubic like it kind of looks. And that one, we would have a place where the derivative doesn't exist. So we have to consider all those. So I'm finding where the derivative may not exist, which in this case would be a pointy point. Let's factor 2x, and then y minus x equals 0. Okay, so 2x equals 0, and then y minus x equals 0. So x equals 0, and y equals x. All right, fantastic, good to know. Well, if x equals 0, we've been through this, but we did it with y. So if x equals 0, this whole thing falls apart. You want to see it one more time? I don't either. So let's not, but I will show you pointing. If x equals 0, then 0 minus 0 equals 1. No, no. So just no. There are no answers that come from this, but we might have an answer that comes from where x equals y. So actually, final answer, if we get an answer from there, if we do, we're going to write the same thing on both of them because x equals y. They're going to be the same, right? So we're going to plug x in for y or y in for x. It really doesn't matter. And I'm going to take that, plug in, all my x's will become y's. I'll do it that way. So x becomes y, so that makes it y times y squared minus 2. And then y squared times y, so y cubed equals 1. Ooh, fun. Negative y cubed equals 1, so y cubed equals negative 1, so y equals negative 1. The cube root of a negative number can happen. The cube root of negative 1 is negative 1. That means if y equals negative 1 and x equals y, they are both negative 1. Fun times, right? Isn't that great? How long was this video? Only 10 minutes. I'm sorry. You know, we should do another one just for fun and make it also the length of a sitcom. Anyway, enjoy.